Here we go. All right, so this chapter is kind of a transition. We've done a lot of algebra type stuff. Okay, solving equations, solving systems, all that stuff was algebra stuff. Okay, and this is we kind of transition now into a combination with some geometry stuff. Okay, so let's talk about first. Okay, this is angles and angle relationships. Okay, this is part one. All right, so somebody tell me, what are some things you know that we already know about angles? Okay, there's some types of angles, right? When we have when we have angles, first of all, what makes up an angle? Okay, we have a ray. Okay, that's two rays. Two rays make up an angle. Remember, a ray has an endpoint and it continues in the other direction, right? Okay, what is that point where they come together called? Anybody know? Anybody? Raise your hand. Anybody?
Is it the vertices?
That's the plural form. Yeah, vertex. Okay, vertex. Okay. Now, sometimes you have points that it goes through. Okay, like you might have a point here, you might have a point here. Okay, and usually those are labeled. Like if this is X, Y, Z. Okay, when you talk about when you talk about what an angle looks like, okay, you'll like on your assignment today, you'll see just an angle sign. Okay, that just means angle. So if I said angle X, Y, Z, okay, the Z and the X don't really matter. They're kind of interchangeable because you don't really start at one and well, it doesn't really matter. What matters is the middle one has to be the vertex, okay? And it's important that you're able to identify an angle because you're going to have several different angles, and you know that middle one is identifying the vertex. So if I saw angle XYZ, that X, see how that middle one is the vertex XYZ. I could also call this what? ZYX. Make sense? Okay. Now, what is an acute angle?
An acute angle is
Less than 90,
degrees.
greater than 0. Okay? What's a right angle? Exactly what?
90 degrees.
90 degrees. And what is an obtuse angle?
Over 90 degrees.
Greater than 90, less than 180. And what is a 180 degree angle?
Straight angle.
A straight angle. Okay? All right. So let's start. Okay, we're going to go to this first part. Okay, what does parallel mean?
That,
Yeah,
that they're the same length.
not
No,
necessarily
not
the same
But
length.
they're like this. So they're like, they don't cross.
Two lines that are never going to what?
Cross.
Intersect. Okay, never. They're never going to intersect. Okay, that's what parallel lines are. Okay, so let's talk about, and why do they have this picture on here? Because what is this gymnast? I'm not going to play the video, but what are these called? Those are called parallel bars, right? Because they're exactly the same. They're the same distance from each other. Okay. All right. Now, when we have when we have a set of parallel lines, okay, let's go. I want to show you back on here. Okay, if we have a set of parallel lines, okay, we have, if something intersects them, okay, let's say I've got this pair of parallel lines. Okay, if I have another line that intersects them, anybody know what this is called? A line that intersects parallel lines?
It's called an intersection.
No. Okay, a line that intersects parallel lines is called a transversal.
I was going to say intraversal.
Okay, transversal. Okay, a line that intersects parallel lines. Bless you. Okay, that's a transversal. Now, how many angles? Let's think for a minute here. Okay, does anybody remember from last year angles on opposite sides of an intersection? Do you remember what those are called?
Equal. Oh, well.
Don't blurt. What are they called? Anybody know? Vertical angles. Do you remember vertical angles? Okay. So in other words, angles that are on opposite sides of this intersection. This angle is going to be the same as this angle. Okay. Those are what we call vertical angles. Okay. And those are angles on opposite sides of the intersection, and they're the same measure. Okay. Now, because these two lines are parallel, this is also going to be the same as this. All of these are the same. Right? Right? Okay, now, what I want you to understand is if you have one measure on a transversal intersection, you can find every other one of the measures. How do you think I can do that? Well, let's say this was 120 degrees. Okay, if that's 120 degrees, how do you think I can use this to find out what this measure is? Yeah?
Okay. Since those two are the same, you add them together and you get 240 degrees. And because the full angle always equals 360 degrees,
All around. You're on the right track, but there's an easier way. Okay? These two right here, guys, from here,
I know.
is this line straight?
No. Yes.
Is this line straight?
Yes.
Yeah. So from here to here, all the way to here, what is the measure of a straight angle? We already talked about it. What's the measure of a straight angle, Jaden? 180 degrees. Okay, so this plus whatever this is are going to equal 180. Well, if this is 120, what does this have to be?
60.
This has to be 60 degrees, which tells me this is also what?
60.
60 degrees, which tells me I already know that this is 120. And because it's a transversal, meaning it intersected parallel lines, this is also going to be 60. This is also going to be what? 60 degrees. All of those are the same degree. Does that make sense? Okay, we had one measure, and we were able to find all those other measures. Okay? Make sense so far? Okay. All right, let's go back and look at some of the other examples. Sorry. Okay, when you see this line, okay, first of all, this is not a parallel set. What is this? Perpendicular. And a perpendicular intersection, what do you notice about the intersection? What does it form? Right angle. Okay? Right angle. So when you see something that's perpendicular to another line, in other words, a perpendicular intersection, do you see this sign right here?
Yes.
See this? Okay, it's an upside down T. Upside down T means perpendicular. Okay? So if we go back to this example, okay, and if I have a line, let's say this is line X and this is line Y, we could say X is perpendicular to what? Y. Okay, does that make sense? Because it formed a what? Because it formed a what? Right angle. The intersection formed a right angle, right? Okay. Let's look at some angle pairs here. All right, so let's look. We know if we're classifying the relationship between angle 1 and angle 7, okay, as alternate interior, alternate exterior corresponding. Okay, what do you think these mean? Okay, there's three things we're going to learn about. Alternate interior, alternate exterior, and corresponding. So if we're looking at angles 1 and 7, okay, just look at this, and what can you tell me about 1 and 7? Looking at what we just did with that other transfer. First of all, is this perpendicular? There's no right angles there, right? What is this line right here? This is a what? Transversal, because it intersects these two what? Parallel lines, right? Okay. So let's think about what do 1 and 7 have in common? Okay, they are, okay, well, first of all, how many angles do we have here? We have 8 angles. Okay. Now, vertical angles. Okay, this angle, is it on the outside of this whole intersection?
Yes.
Which exterior angles do I have here?
1,
Angle 1, angle 2,
8, 7.
8, and 7. What interior angles do I have?
4,
4, 3, 5, and 6. You understand the difference? Yeah? Okay, now, alternate exterior angles. That means that if I have an angle on the outside over here, according to what we just did, okay, remember, vertical angles, meaning these are opposite sides. These are what? If they're vertical, they're what?
The same.
They're the same, which means because these lines are parallel, these are the what?
The same.
Same as these. So if I have an angle measure for angle 1, do I have an angle measure for angle 7?
Yes.
I do. Okay. When they are the same measure, okay, when they're like vertical angles, but they're on the outside, that's what we call alternate exterior angles. Okay. Does that make sense? Because they're on the outside and they have the same measure. Alternate what? Exterior angles. Do you think we have, not looking at angles 1 and 7, do you think we have some alternate interior angles here?
Yeah.
What would 3 be the same as?
8,
As what?
7. No, 8, 7?
5, okay. Because look, these are the same, and these are the same. So 3 is an alternate interior angle with 5. What would 4 be an alternate interior angle with? 6, okay. Does that make sense? Yeah? Okay. All right. So let's look at this example, okay? If I were to say, classify the relationship between angles 4 and 6, what did we just classify those as? Say it. Alternate interior angles. So we are correct. Good. All right. Does that make sense what the difference between those is? Okay. Now for classifying angle pairs, okay, classify the relationship between 2 and 6. 2 and 6. Are these going to be the same?
No.
Now, one of these is where?
Rhyme.
Guys, look. Where are my exterior angles on these intersections?
1,
1, 2, 7, and 8. So what is an alternate exterior to angle 2?
Diagonal exterior.
Angle 7, right? Okay. But what they're trying to compare here, angle 2 and angle 3, and angle 6 and angle 7, one of these is exterior, one of these is what? Okay, when one is exterior and one is interior, but they have the same measure, what do you think those are called? Corresponding. Okay, those are what we call corresponding sides. Okay, does that make sense?
When they're like,
Because see, look, this is going to have the same measure as this, this, and this because of the transversal. So one of these is outside. See how this 2 is on the outside? This 6 is in an interior angle. Okay, so they can't be alternate exterior or interior. Those are what we call corresponding angles. Okay, does that make sense? Yes? Okay. We can just look at, oh, I was shaking. Okay, corresponding angles. Okay, does that make sense so far? Okay, so let's look at this one. Okay, what about 4 and 8?
corresponding.
What about 4 and 8? What are those? They're either interior, alternate exterior, or corresponding. What do you say?
Corresponding.
Everybody says corresponding. Why? Because one of them is
Interior.
exterior. And do they have the same measure? Do they have the same measure? Yes, they do. Now, what if I said 4? Are you sure 4 and 6? I mean, what if I said 4 and 3? Okay. Do you think those have the same measure?
No.
No, but we're going to learn about what those are. Okay. Are we good so far? Okay. All right. Now, missing angle measures. Okay. Did I already kind of go through this a little bit? We did. We learned if we have a transversal, okay, remember 2 parallel lines are cut by a transversal. Yes, 8 angles are formed. Okay, and we know how to find that missing angle. Okay, so if we're looking at something like this, okay, line A and line B were cut by this transversal. Okay, if the measure of angle 2 was 105, okay, this one is 105. Okay, before we do any serious math, what do we already know?
That 2 and 5 are the same.
That 5 is also what?
105 degrees.
Everybody tell me. 5 is also what? 105. Which means also 4 is what?
105.
And 7 is also, because 2 and 5, those are vertical. 2 and 4 are what? Corresponding. Okay. 2 and 7 are what? Alternate interior angles. Okay. 5 and 4 are also what? Alternate exterior angles. Okay. So if this measure of angle 105 was, or measure angle 2 was 105, what do we know that these two angles together equal?
They have to equal 180.
Okay, what do these two angles together equal?
180.
180, because they form a what? Straight angle. So all I have to do to find out what angle 6 is what? Take 180 and subtract what? 105. Okay, so if I take 180 and subtract 105, okay, tell me what I get. You can do that in your heads, right? What do I get?
75.
75. This should be, well, since 2 and 6 are supplementary means they add up to 180. Okay, then I can take that from, if I subtract that, it's 75. So now that I have angle 6 is 75 degrees, right? What other angles do I have? 1, 3, and 8. Okay, because those are also vertical angles. What is the relationship between 1 and 8? What are those? Alternate exterior angles. What about 2 and 3? Are they corresponding? They're not either one. Okay, because they're on the same side. 2 and 7 are alternate interior. 6 and 3 are alternate interior. Okay? But I'll tell you, 2 and 3 actually are what we call supplementary angles because they add up to 180 degrees. Okay? All right, is this making sense?
If they're on the same side, they add up to 180.
If they're on the same line. But they would still add up to 180 degrees. Okay? All right, so let's see if you can answer this one. Find the measure of angle 8 and angle 7. It's kind of hard to see. Look, this is 1, 2, 3, 4, 5, 6, 7, 8. Can you find, if this angle right here is 53 degrees, can you find out what this is?
Yeah, 53.
Do you have to do any math to figure that out?
No.
What is the measure of angle 8? Everybody.
53.
Why did only 3 people tell me that? If this is 53 degrees, what is 8? Why? Vertical, right? Alternate exterior angles. Good. What about the measure of angle 7? How can I find this? Somebody, how would I find this? One person is not enough. How can I find this? This angle right here. If this is 53, how do I find this? Subtract it from what? 180. Okay, so what would that be? 127. Good. All right. Do we understand how this works now? Pretty much? Okay. Now this next part, and we'll go into this more. Okay, what do you notice about this?
There's a lot of it.
This is kind of crazy, isn't it? Yeah, there's all kinds of stuff. Now, if you were to take out, well, just look at this. Truthfully, this is just a what? If you didn't have this line here, what would you see here?
Or a transverse.
Transversal, right? And if this one was gone, what would you see here?
A transverse.
All you have here is an intersection that is parallel. And what does the other intersection form?
Transverse.
Well, look at it. What does it form?
An X.
Do you see this right here? Okay, so I have a perpendicular intersection and a what?
And a straight line.
And a parallel line, okay? So basically I have two transversals that form a perpendicular intersection. So let's think about this, okay? This seems crazy, but it's actually pretty easy. If I know angle 1, what other angles do I know?
9.
9, what else?
6.
3 and
6.
6, okay? Now, if I know 3,
You know.
I already know this because what is it?
Right angle.
It's a what?
Right angle.
Which means what's its measure?
90
90 degrees. So if I know this and this, can I find this?
Yeah.
Yeah. Okay. And this is going to be the same as what?
Say 4.
4. Okay. And if this is 90 degrees, what is this? 90 degrees. Okay. So if you had one angle measure here, would you have enough to find everything else? Okay. So if we know that angle 1 is 40 degrees, right? You with me? Okay. If angle 1 is 40 degrees, what is this?
40 degrees.
What is this?
40 degrees.
What is this?
40 degrees.
So if this is 40 degrees, what is this?
90 degrees.
So what's 40 plus 90?
130.
130. Okay, and they want us to find in the figure line M is parallel. What is the measure of angle 7? This plus this is 130. Well, what does this have to be?
50 degrees.
Okay, did we find that by using only one angle measure?
Yes.
Yes. Okay, do you understand how we did that? Because this angle is 90 degrees, and we know that this and this and this and this are all the same. So if this is 40, 40 plus 90 would be 130, right? This is a straight line, and any angles on a straight line add up to 180, right? So we take 180 and subtract these two, which is 130, and we get 50 degrees. Okay? Does this make sense? It's pretty easy, isn't it? Okay.